Hi everyone. In today's lesson, we're going to talk about limits day 3. The goal it will be to evaluate limits that result in 0 over 0, but now we're going to use another method called conjugates. So, again, this picture won't be there for your problem set, but it's here so you have a visual representation of what's happening. So I want to find the limit as x approaches 16 of this function. So from the picture, you should be able to tell that the limit from the left is equal to the limit from the right, and it's at this y value over here somewhere. So we know the limit is going to exist. We know there's going to be a hole. So if we follow the steps that we used yesterday, we're going to do direct substitution first. Plug in radical 16 minus 4 over 16 minus 16. Square root of 16 is 4. 4 minus 4 is 0. 16 minus 16 is 0. So 0 over 0 tells us we have a hole. So normally you would be thinking factoring, right? That's the only way I've taught you how to get rid of or dig yourself out of the hole, if you would. But because I have radicals, we have to use something called conjugates. So I just want to define what a conjugate really means. So let's just say I have radical x plus 7. The conjugate of radical x plus 7 is radical x minus 7. If I had radical x minus 3, the conjugate of radical x minus 3 would be radical x plus 3. So all that conjugate means, it means to switch the middle sign. So switch the middle sign of a binomial, something that has two terms. So the plus went from a minus and the minus went to a plus. That's all that conjugates mean. And we're going to use this theory to help us dig ourselves out of the hole because factoring doesn't apply here. So I'm just going to rewrite the problem just so I have a little bit more space. So I want the limit as x approaches 16 of rad x minus 4 over x minus 16. So instead of factoring, we're going to multiply the top and the bottom by the conjugate of the radical. So of this rad x minus 4, would you agree that the radical is rad x plus 4? So the rule says if I have a radical, I multiply the top and bottom by the conjugate. Okay, so we started with rad x minus 4, so we just make it rad x plus 4, and we multiply that by top and bottom. And then we just do some algebra to solve. So the algebra is not going to be that bad, it's just a little bit of double distributing. So rad x times rad x, you should be telling me is just x. The square roots cancel each other out. Rad x times 4 is 4 rad x. Negative 4 times rad x is negative 4 rad x. And negative 4 times positive 4 is negative 16. Now, a nice algebraic trick is that you don't have to double distribute this bottom. So you only double distribute the conjugate pair, the rad x minus 4 and the rad x plus 4. And you're going to leave this bottom completely alone. And I'm going to show you what happens. So we're going to leave it as x minus 16 and rad x plus 4. So if you look at the numerator, you should notice that this positive 4 rad x and this minus 4 rad x should cancel. So what you're left with is just x minus 16 over x minus 16 times rad x plus 4. So what you should notice, since we didn't double distribute this, see how we have an x minus 16 and an x minus 16? That's perfect. They cancel, and we have a 1 on top. So our final answer is 1 over rad x plus 4. And then the same steps apply as we did yesterday. We're going to try again now. So we're going to do the limit as x approaches 16 now of 1 over rad x plus 4. This is the new fraction. So we're going to use direct substitution, and we're going to plug in 16. So 1 over square root of 16 plus 4. 1 over square root of 16 is 4. 4 plus 4 is 8. So 1/8 is our final answer. And that makes sense, right? 1/8, it would be the fraction between 0.1 and 0.2. 1/8, I believe, is 0.125. So that works beautifully. So same steps, except instead of factoring, we're using conjugates. Let's try another one. All right, same example, same type of example. And I want the limit as x approaches 1. So again, this picture won't be here, but let's see if we can at least guess what it's close to. So as x approaches, here's 1. From the right and from the left, looks like it's approaching the same y value of 4. So let's look out for 4 to be our final answer. So step 1, direct substitution. So I'm plugging in 1. So 1 minus 1 over the square root of 1 plus 3 minus 2. 1 minus 1 is 0. Square root of 1 plus 3 is the square root of 4 minus 2. So 0 over square root of 4 is 2. 2 minus 2 is 0. So 0 over 0. So we prove that we have a whole. And normally we would use direct substitution. Factoring, but we have radicals. So step 2 is simplify using conjugates. So I'm going to just rewrite it as x minus 1 over rad x plus 3 minus 2. Now, you're probably thinking that this one is a little different. It is, because it has that plus 3, but the conjugate is still the same thing. Switch the middle sign. Only the middle sign between the radical and the number. So the conjugate would be rad x plus 3, then plus 2. So again, you're only changing that middle sign, and we're multiplying that thing to the top and the bottom. And if we remember the algebra trick, we're only going to multiply the conjugate pair. This we're going to leave alone. It's just flip this time. So the top we're going to leave alone as x minus 1 times rad x plus 3 plus 2. We're going to leave that alone, and we're going to double distribute the bottom. So this times this, rad x plus 3 times rad x plus 3. Anything times itself, the radicals cancel, x plus 3. This x plus 3 times 2 is plus 2 rad x plus 3. This times this is a negative 2 rad x plus 3. And then the negative 2 times positive 2 is negative 4. So you're going to notice that those are like terms and they're opposite, so they're going to cancel each other out. So if we simplify it, the top stays as x minus 1 times rad x plus 3 plus 2. And the bottom can simplify x plus 3 minus 4. So I can combine the 3 and the negative 4 to x minus 1. And you should notice that the x minus 1s will cancel. And I'm left with this as my simplified version. So step 3 is to try again. So I want to do the limit as x approaches 1. But now of this, of rad x plus 3 plus 2. So direct substitution tells me I'm going to substitute 1 in for x. And the square root of 1 plus 3 is really saying the square root of 4. Square root of 4 plus 2. 2 plus 2 gives me 4. And that is my final answer of my limit. All right, so let's add to that limit flowchart from yesterday. So the first step is always direct substitution. And if you plug it in and you get a nice number, then life is beautiful and you're done. Okay? If you plug it in and you get 0 over 0, that means that you have a hole in the graph. And yesterday we learned a way to get out of it. We learned factoring. And today we learned that you can use conjugates. And then after you try those two options, then you try again. And when you try again, then you should have a nice pretty number, and that is your answer. So all that I did today was just add another type of way to dig ourselves out of that hole. We can do factoring, we can do conjugates, and then that's it. Tomorrow you will learn the last way to get out of the hole. So if you have any questions, please let us know, but that is it for today. Have a good one.